Good evening, everyone. My name is Mansi Tripathi. I am TA for the course Environmental Chemistry. So, this is the fourth week of the course. We'll start with some recap. We'll see the some background and introduction, whatever that has been talked in the previous week. Then we'll see some question answer, which are like for this week. It was soft. There was software also, so we'll see that too. After that, in case of any doubt, you can ask any questions. So we'll try to solve that as well. So I'll share my screen now, then we'll start the lecture. I hope it's visible. So this is the fourth week recap. We have seen what is ionization functions, which was in terms of alpha naught, alpha 1 for monoprotic acid, alpha naught, alpha 1, alpha 2 for diprotic acid. This was for monoprotic. Then we have seen some models, multiple reaction problem, in which either single component was in was single acid, single base. Then there were problem for both the acid and bases. Okay, all those things. Then we have seen some recipe problem. In recipe problem, we have seen how the different volume of a particular acid or base or two different acid or two different base can react, and we can find out the pH of the same by using visual Ventek and some background. Then we have seen the inverse problem, in which we know the target pH, but we need to play with the concentration of the various components to find out the amount of component. All these things we have seen by doing the manual calculation as well as software program, which is vMinTech or Visual Mintek. So if you have not yet downloaded this thing, please download it. It is easily available. You can just type it in Google and download it. There will be the newest version is available, I think, for this July 2024. The newest version is available. I think that is version 4. So whatever is this was basically of by using we wanted to solve the system set equilibrium. So we needed to do the component balance, but there are other things that can be used for the solving at equilibrium when you are trying to do it manually. First is mass balance. Whatever mass is going in, the same mass should come out. So in all the examples, whatever we are doing, we like, for example, HA is dissociating into H plus and A negative. We know about water also. H plus OH negative. So the things that we are taking as H total, right? H plus total is everything. H plus HA minus OH negative. So at different pH, there can be changes in H plus, HA or OH negative, but overall this H total will remain same. So that is mass balance. Second thing is charge balance, in which the overall positive charge is equal to overall negative charge. Okay, there comes the equilibrium equations. What are equilibrium equations? If we look for this, the K will be, the acid dissociation constant will be H plus A negative, then HA. So this is equilibrium equation. Similar equation can be used for this, in which we can find water dissociation constant. The last thing is component balance. That is what we have seen in the entire lecture. We need to find out species, like for the above example that we have seen of HA. So what are different species? H plus. You can write down in the chat box. H plus, HA, A negative, OH. These are the species. Now we can find out component. Component is the building block, the minimum number that can be used to make up all the species. So one is always H plus, other is most deprotonated form. Okay, here these two will be enough to form each and everything. Then we form TW or the formation equation before that, but we'll directly go with TW. We will write species here. And here we write component. Like this 1, 0, 1, 1, 0, 1, minus 1 and 0. Hmm? And what is our recipe? Recipe is HA naught, which is 1, 1. So while finding out H total will get this. Okay, and let's find out what will be the A negative total. This will be equal to HA plus A negative. This is our 80. So this is how we do component balance. So let's solve some questions now. A monoprotic acid HA dissociates in water as below. HA, H plus A negative, as we have seen in earlier slide. Now the pK value comes out to be 3.29. The concentration of deprotonated form is A negative, and the concentration of the deprotonated form A negative and A total at equilibrium is 10 raised to power minus 48 and 10 raised to power minus 3 molar. What will be the pH of the solution? This question is very simple. You can use Heisenberg equation. Also, be very careful that here A negative is given, A total is given. You need to find out HA. Okay, so take some time and try to find out the answer of this question. We'll see the solution in a while. Okay, what is that equation that we can use to find out? I'll give you the hint. pH is equal to pKa. We have pKa value. We need to find out the pH plus log. This is 10th log. Okay, here 80 is given. Now you can use the hint and find out HA. What is HA? What is A total? Let's see. A total is equal to now you can find out HA and solve the question. I'll give the solution in a while. Please try to solve this question. We'll see the solution now. So here A negative is 10 raised to power minus 4 at molar, AT is 10 raised to power minus 3.5 and pK is 3.29. This is given data. From the Henderson-Hasselbalch equation, we have seen this thing that I have written in the previous slide. From the component balance, we know AT is HA plus A negative. So what is HA? 10 raised to power minus 3.5 minus 10 raised to power minus 4.8. This is what we got. Then we will put this thing in equation 1 and pH is equal to 3.29 plus log. This is A negative, this is Ha. So this is the pH that we have got, that is 2.01. So the correct answer is D, 2.01. Please note down the following so that we can move forward to the next question. Coming to the second question, acetic acid dissociates in the water in the following manner. Okay, we know the pKa, which is 4.76. We now know the pH of the resulting solution. The concentration of acetate ion at equilibrium. Calculate the total concentration of acetate in the solution at equilibrium. Here also Henderson-Hasselbalch equation will be used. Here AC total is given. Okay, be careful and solve the question. We will see the solution in 1 or 2 minutes. Here for this question, okay, first of all, we know the pH. So pH is equal to pKa plus Ha upon A negative upon Ha. So pH is 5, which is equal to 4.76 plus logarithm of, we know A negative to 10 raised to power minus 2.3 divided by HAC, because we don't know the value. From this HAC can be calculated and ACT is HAC plus AC negative. Taking the hint, please try to find out the solution. We'll see the solution in the next slide. But before that, you can try it on your own. We'll see the solution now. So the answer is 10 raised to power minus 2.1 molar. Let's see how. This is the given data. Sorry, this is the given data. From the Henderson-Haselberg equation, we got HACS 2.884031 10 raised to power minus 3 molar. From the component balance, we can find out total amount of acetate, which is the sum of protonated acetate and acetate ion. Coming back to question number 3, compute the pH of 5 into 10 raised to power minus 8 molar HCl solution. Ignore the effect of ionic strength and assume AI is equal to Ci. Here, important thing is we know that it is a strong acid. So what we will usually do, we will report pHs as 10 raised to power 8. Okay, but that is not the case. Try to use the water dissociation constant as well and try to find out the answer. You can use visual Mintek as well. We'll see the solution in a while. Please try this thing. Coming to the solution, the answer is 6.89, and this is the range in which the answers can be taken as correct, because it is not a multiple choice question, so you can write answer in a particular range. From the given data, HCl is HCl naught is 5 into 10 raised to power minus 8 molar. As we know that pK is less than 0 and it will dissociate completely at most of the environmental conditions. So total HCl at equilibrium is 0. So what all the species that we have? H plus, Cl negative, OH minus, and this is the component. So this is the table that we can form by using that. Now these are the formation equations. Okay, H total is equal to H plus minus OH, and Cl total is equal to Cl minus. Either you can directly go to Visual Mintek and solve the problem, or you can solve by using dissociation constants. So our HT is H plus minus OH minus, which is equal to HCl. Now how we can replace OH by Kw by H plus? How this is happening? Water dissociation constant is equal to H plus and OH minus. Okay, so just by replacing OH with Kw upon H plus. So this is how we got this thing, and HCl naught is the initial value that has been used. Now just by solving this quadratic equation, we can solve this in calculator or manually as well. We get H plus as this. So what is pH? pH is negative log of hydronium ion concentration. So pH what we got is 6.89. Moving towards next question. Oh, first I think I should give you the time to note down this thing. You can note it down, then we can move forward to the next question. We'll see next question now. Cyanide ion is vital in metal plating industries because it can keep metals dissolved under conditions where they would otherwise form solid precipitate and settle out of the solution. It is essential to maintain pH more than 10.5 in this solution to minimize the release of toxic hydrogen cyanide gas. So they need to form the equilibrium between the gas and so we'll write the equation HCN. Oh, sorry for this. So if this is the solution, if HCN is in liquid phase, it will be in cyanide form, cyanide ion form, or if it is out, it will be in HCN form, if it is in gaseous form. So the pH of the solution should be maintained more than 10.5 if we want to retain it in cyanide form. If the solution is prepared by 10 raised to power minus 2 molar NaCN in water, select whether the below statement is true or false. The pH of the solution will be in the range to minimize the release of toxic gas. Okay, so what is basically happening? This is HCN and this is cyanide ion. The pKa value of this reaction is 10.5. So, if the pH is more than 10.5, it will be in the dissolved form rather than being into the gaseous form. So, the pH should be more than 10.5. So, how we can solve this question? This is the molar concentration of NaCN which is added in water. We need to just select if the pH is greater than 10.5 or less than 10.5. So, try to solve this question. Let me know the answer in the chat box. We'll see the solution now. NaCN naught is 10 raised to power minus 2 molar. No other sources of NaCN are there. So we can say that Na total and Cn total is this. Just we need to feed this thing in visualmente and the pH of the resulting solution what we get. We'll see how this is being done. So 10 raised to power minus 2, right? NaCN. Cn 10 raised to power minus 2. add to list, and the other thing was sodium. We'll remove other things and we'll run the software. Okay, it's not coming because H plus and all those things will also be there, no? Not only these things, but other thing also will be there. So we'll write we know there will be water dissociation as well. So what are the component that we have? Species H plus, Cn minus, HCN, and we have what? OH. We have NaCN as well, but let's not. Okay, we can take that also, and Na. Hmm? And what are our components? H plus, Cn, and Na. Okay, then we'll solve for different species. This will be 1, 0, 0, 0, 1, 0, 1, 1, 0, minus 1, 0, 0, this will be 0, 0, 1. So Cn total is 10 raised to power minus 2. Okay, no other source is there. Na total is 10 raised to power minus 2. Okay, and what is our H plus total? Is equal to H plus HCN and OH. This will be in minus, and here it will be in plus. Please note down this thing, then we'll see further. Okay, so as since there is no source of H total, it will come 0. That's why we will directly feed Na and this thing. So we'll see what is happening with Visual Mintek. So NaCN was there, right? We'll see the list. Cn negative is 0.01 and Na1 is 0.01. Okay, back to main menu, then we'll run the software. Why it is not coming? The pH is not coming. I have to check that. Okay, maybe this is the problem here. Yeah, I was not checking the values here properly. Back to main menu, then we will run. Now let's see. Still there is some problem. Okay, Molal was not selected. Mhm. Okay, see, the software is like this. If you are doing a single mistake, it's being like this. So we have to be very careful while solving the problems. I think I need to check this later. I will check this. What is the issue? But you can solve this by just putting the value in Visual Mintek. I'll check what is the problem with there with the software. Coming to next question. A solution is formed by mixing equal amount of H2SO4 and Na2SO4. Initial concentration of H2SO4 and Na2SO4 are 10 raised to power minus 3 molar and 10 raised to power 4 molar. Assume both the compound dissociate completely and can be neglected at equilibrium. Find the pH of the resulting solution. Please try to find out the answer of this question. Write component balance equations, everything. Then you can check for the Visual Mintek to find out the solution. We'll see the solution now. It is 2.75. So H2SO4 is 10 raised to power minus 3 molar and Na2SO4 is 10 raised to power 5 minus 4 molar. These are the species and the components, and this is the W that was used to find out the component balance. So sodium total is 2 Na2SO4, therefore 2 into 10 raised to power minus 4 molar, and sulfate is 1 SO4, which is being given with this equation, and H plus is 2 into 10 raised to power minus 3 molar. Now we will feed these values in Visual Mintek. Okay, please note down this thing so that we can feed the values. We'll feed the values in Visual Mintek now. Na is 0.002. Add to the list. Other component is sulfate. Sulfate. This is okay 1.1 into 10 raised to power minus 3. pH is 2.756. So we are just feeding these values and 2.756. So 2.75 is the pH. Coming to the next question. Significant inhabitants of cities suddenly suffer from waterborne disease. As being an environmental engineer, you are advised to check various parameters of potable water supplied across the city. Parameter includes both chemical and biological. After assessing the influent and effluent of the water treatment plant, you found out a class of bacteria present in the water causing the outbreak in the city. Luckily, after laboratory testing, it was noticed that the bacteria only survive in alkaline water. Okay. To control pH, 6 into 10 raised to power 4 molar HPR is added, propanoic acid, which reduced the pH of the water to 4.018, which destroyed a significant population of bacteria. Now we need to neutralize the water. So 3 into 10 raised to power 4 molar NaOH is added. pH increased slightly. So we need to, and for decreasing more H plus ion concentration, again 2 into 10 raised to power minus 4 molar sodium pyrite or sodium NaPr. A salt is added to water. What is the pH of water? So three salts are there. You please note down the molar concentration of all these three salts, make the tableau, find the component balance, then we can easily solve this in Visual Mintech. Please note down the question so that we can move forward. We'll see the solution now. It is 5.11. How? What we are doing? We are adding 6 into 10 raised to power minus 4 molar of HPr, 3 into 10 raised to power minus 4 molar of NaOH, and 2 into 10 raised to power minus 4 molar of NaPr. So total HT is HPr minus NaOH. This how we got? We got from component balance. I won't go into details. In case of any doubt, I'll let you know. Please write in the chat box. Propionate. This is the term that we can get in Visual Mintech. Propionate minus 1. So HPr plus NaPr, which is coming from HPr and NaPr. So similar thing we have written here. Na total is NaPr plus NaOH. We will feed the above values in Visual Mintech. Please have a proper look on this so that we can move forward and feed this thing in Visual Mintech. Okay, moving forward, we will just keep these values H plus, propionate and Na plus in Visual Mintech. Then we'll click on here back to main menu, and then when we'll click run, we will get the following result. And the pH that we got is 5.11. Okay, please note it down so that we can move forward. How the steps were done. Moving towards next question. Hydrofluoric acid is weak acid. pK is 3.17. That is used extensively in industry because fluoride ion attaches firmly to iron and aluminum ion. As a result, it is an excellent reagent for removing surface scales from objects made of iron and aluminum before they are painted or other surface finishing operations are carried out. Compute the pH of the solution prepared by adding 10 raised to power minus 3 molar of HF to pure water. Okay, since it is weak acid, water ionization will also be considered. Please keep that in mind. Prepare species, W and other component balance, then we'll see the solution. So the pH is 3.26. Let's see how. HF, initial HF concentration is 10 raised to power minus 3 molar. H total is H plus HF, which is equal to HF naught, which is equal to 10 raised to power minus 3 molar. This we got from the table of component balance. Total fluoride ion is HF plus fluoride ion plus HF, which is equal to HF naught, which is equal to 10 raised to power minus 3 molar. How do we write HF as ionization fraction? Alpha naught. HF is equal to alpha naught multiplied by total fluoride is equal to H plus upon Ka plus H plus F total. So from putting this thing in equation 1, we will get H plus H plus upon 10 raised to power minus 3.17 plus H plus into 10 raised to power minus 3 is equal to 10 raised to power minus 3 molar. We can then we can solve this and we will get pH is equal to 3.26. This can be done in Visual Mintek as well, taking care of the water splitting. Question number 8 is, a solution is made by adding 10 raised to power minus 3 molar HOCl and 10 raised to power minus 3 molar NaPr to the water. When NaPr is dissolved, sodium ions are released and undergo no further reaction. Then NaOH is added until the solution pH is 7. How much NaOH must be added? Okay, please try to find the solution for this question. Then we'll see the solution in a while. Moving towards the solution, the answer is 2.22 into 10 raised to power minus 4. Let's see how. HCl initial HCl concentration is 10 raised to power minus 3 molar. NaPr initial concentration is 10 raised to power minus 3 molar. pH is 7. So the species that we can be identified are H plus, OH minus, HPr, PR, HOCl, OLC ion and HNA ion. These are the components. These are enough to make all these species. And looking at the relevant reactions and the W, also equilibrium relationships are also required for additional equations. So, the dissociation constant of water, acid ionization constant for HPr and for HOCl. Acid dissociation constant, sorry for calling it ionization. So, then we can do the mass balance. We have no idea for NaT, and here we have to do charge balance also. Okay, in this problem, Na total is unknown since we do not know how much NaOH has been added to adjust the pH to 7.0. Okay, that's why it is unknown. Therefore, we have three equilibrium expressions, two mass balance and one charge balance to work with, six independent equations. There are 7 species in the system, but one of them is H+, for which the final concentration is specified. Thus, the number of equation 6 matches the number of unknowns and the problem can be solved. Okay, whatever the questions that we have seen earlier, charge balance was not required, but here it is required as the number of equations are not enough. Putting all those values in charge balance equation, we get Ha plus Na plus is equal to Kw upon H plus alpha 1 of HPr and the relevant concentration and alpha 1 of HOCl into OCl ion total. Calculating ionization fraction, it can be easily calculated. You know how? KHCl, all these questions are there, how we can calculate the ionization fractions. Then we can substitute all these values in the charge balance equation. Here we can get 10 raised to power minus 7 plus Na is equal to Kw upon 10 raised to power minus 7 plus 0.228 plus 0.993. After that, 10 raised to power minus 7 Na, 10 raised to power minus 14 divided by 10 raised to power minus 7. What is 10 raised to power minus 14? As we have seen earlier, this is coming from dissociation of water constant. Now this equation can be solved for Na and this is what we got. Okay. So we know this is Na total. Oh, we get Na as Na positive, that is 1.221 into 10 raised to power minus 3 molar. Because Na positive is the only form in which Na exists in the equilibrium solution, we can equate this value to Na total. In addition, we can write the mass balance of Na in terms of input species as NaOH is equal to NaT minus NaPr. So this can also be written, and this is how we have solved this. So we conclude that 2.22 into 10 raised to power minus 4 molar NaOH was added. So this question was quite different from the other questions. So please look at this properly and let me know if in case of any doubt you are getting. So coming to the question number 9, what will be the pH of 100 ml of 1 into 10 raised to power minus 3 molar sodium hypochlorite, to which 25 ml of 2 into 10 raised to power minus 3 molar HCl is added? Here, this type of question we have seen in class lecture. If you have checked it properly, you can easily solve this. It can be solved using visual Mentek. However, we will need to write the component balance properly. Here the conservative quantities are what? They will be the total species. Na total Na positive, total OCl positive, total Cl negative. Okay, these will be the species. Okay, conservative species. So please use all those things, all the concepts, and try to solve this question. We'll also see the solution in a while if you can do this properly. The solution for this question is 7.52. Now try to solve this and get to this solution. Moving forward, sodium hypochlorite is given as 1 into 10 raised to power minus 3 molar and HCl is given as 2 into 10 raised to power minus 3 molar. We have as total of NaCl and all other totals. Okay, this we can get from the component balance. Okay, OCl is coming from one source, that is why only 1 into 10 raised to power minus 3. Sodium is coming from one source, chloride is coming from one source. Chloride total is from NaOCl is 0. H total coming from HCl is 2 into 10 raised to power minus 3. And OCl total from HCl is 0 and all other things. So these all are conservative quantities as we have discussed before. So this can be used to find out the total of the mix. This is how it is done. Then we just have to feed this all values in Visual Minter and we will get our pH. So please note down this slide properly so that move forward to the last question. This is all the play of just finding the right concentration of the components. Rest of the things Visual Minter can easily do. Moving towards last question. You have a flask in a laboratory on which the label is smudged. From what you can read, it is a solution of monoprotic acid. We call it HX at the concentration of 2 into 10 raised to power minus 3 molar in a 0.05 molar NaCl solution. You measure the pH of the solution and get a reading of 3.09. Determine the pKa of the acid. Please try to solve this question. We'll see the solution in a while. So to solve this question, we have pH, target picture. This is the inverse type of question. We have the final pH. We have H plus S 10 raised to power minus 3.09. From the given data, H total is 2 into 10 raised to power minus 3 and Xt is 2 into 10 raised to power minus 3 molar. NaT is 0.05 and Cl is 0.05. We know that alpha naught is equal to Hs upon Xt. Okay, Ht is Hx plus H plus minus O negative. So what is Ht? Ht we know as 0.002, which is Xt total. Therefore, Hx concentration we got as this. So alpha naught is this. Alpha naught is equal to H plus upon H plus plus Ka as well. So from here we got this Ka. So by putting pKa is equal to 3.25. So that's all for today. You can stay back and ask your doubts.